This video gives you a quick study guide on Chapter 10, Object-Oriented Thinking. The focus of this chapter is on class design and explores the differences between procedural programming and object-oriented programming. The chapter shows you how procedural and object-oriented programming differ. You will see the benefits of object-oriented programming and learn to use it effectively. In this section, you'll learn what is class abstraction and encapsulation, and we'll use the loan class as example to design a class and to get all the relevant information for the loan in one class. So here's the loan class, and with the data fields, annual interest rate, the number of years, loan amount, loan date, and the loan date is and when the loan was created. And the loan date has the data type as the java.ut.date, and which was introduced in the previous chapter in section 9.6. Here are the constructors, two constructors. The first is the no-arg constructor to construct a default loan object. The second one is to construct a loan object with the specified interest rate, number of years, and loan amount. And those are the get methods, and for the data fields, set methods, and for the data fields, and the methods for getting monthly payment and getting total payment. Now, with this UML diagram, and assume the class is available, you can write a test program and now you can write the implementation. Now please note that this pedagogic tip here, it's very important. Now please note that using the class and the writing class are separate tasks. And from now on, and we are going to first design the class and then write a test program, and afterwards and we'll write the implementation. So by doing this, there's three benefits. And first, it demonstrates that developing a class and using a class are two separate tasks. It enables you to skip the complex implementation of certain classes without interrupting the sequence of this book. It is easier to learn how to implement a class if you are familiar with the class by using the class. Now let's look at the section 10.3 on thinking in objects. We will use this example, the BMI, body mass index. The problem was introduced in section 3.8. In 3.8, we just write everything in the main method. And now we're going to design a class to make it the code more usable and make all this information coupled in one object. So we're going to design this class BMI, and with all this information in one place, and this is the name and age, weight, and the height, and all this associated with a person's information, and from here we can get to the BMI, the constructed BMI objects, the two constructors, and this is the get BMI, the index, and the get the status, interpreting the BMI. And given this design, and assume that the class is implemented, we can write a test program, and this is the test program creating BMI, and with the name, age, the width and height, so we can get the information, and for the BMI and the status. And the example here is to create another object, and we can get the BMI and status for this object. And this is the implementation for the class. And see the implementation, and most of the methods are very simple to implement, the get methods. So the constructors, and get BMI and get status. All right, next, and we will turn our attention to discovering class relationships. To design classes, you need to explore the relationships among classes. The common relationship among classes are association, aggregation, composition, and inheritance. We're going to introduce inheritance in chapter 11. So now we're going to focus on the association, aggregation, and composition. And so please read this section and to understand what is association and what is the UML graphic notation to describe association. And the next subsection here on aggregation and composition, understand what is aggregation and what is composition. So why we're going to treat all this as composition when we design in class. So please read and all the way and see this important note. All right, so now we're going to move on to a case study on designing the course class. So we're going to have this class course, and to describe a course and to get the information in a course. So this is the course name, the students in the course, and the number of students in the course. And there's one constructor here is to construct the course with a given name, and the methods, and get course name, add a student, drop a student, get all the students from the course, and get the number of students in the course. Now, those are the private data fields, and when you use it, and you really don't need to care about it, and all you need is to use the public members and the constructors and methods, and to use it. So with all this information, we can write a test program and to use the course, and creating course, add students to the course, and to get the information from the course, all the students and the number of students. And now we turn our attention to implementing the class. So here, when we implement the class, say, look, we use the array and for the students, and we assume the maximum number of students, and here is 4. And so this is the constructor. So this is the method to add a student, and here the drop student is left as exercise, so please complete this method. Now, as you see here, we have the array is fixed for number of students. This is the maximum number of students you can add into this course. Now you can modify this program and to make it flexible, So when you have more students adding into the course, if it exceeds the capacity, and what you can do is to create a larger array and for students, and copy the existing one into this new one, and make this new one as the students' data field. So the old one is discarded. So that can be done, and you can look at the programming exercise in 10.9 and for the additional information. So please, this is good exercise and to do. All right, another case study for designing class. We're going to design a class for stacks. Stack is very popular data structures in computer science. It is the last in, first out. So here, look at the animation. We have the stack for integers. So let's have 23, and so operation is here's the push into the stack, and then 12 and 25. All right, so now when you remove elements from the stack, you always remove from the top, and you can see it just peek from the top. So here's the top element is 25. All right, so now let's remove it, and you see remove it and from the top. So now the stack is empty. All right, so we're going to design this stack class and call this as a stack of integers, only for integers. The elements is the array of the integers, and this is the size, specify the number of integers in the stack, and there's two constructors. So one is no arg, and so you have a default capacity 16, and this is the constructor empty stack with a specified capacity. The methods empty to test if stack is empty, peek, push, pop, and get size. All right, with all this information, now you can write a test program using the stack. And now let's implement it. So here is the code and to implement the stack. All right, this concludes the first part of chapter 10, and we will present the second part in another video.